Hello, welcome to Minecraft Mathematics, or whatever this series is going to be called. Anyway, today we are going to be doing the 1998 AP Calculus FRQ. This is no calculator, or this one you don't need calculator, at least. I don't know how the test has changed, but for your current test, you'll have a calculator question and a no calculator set of questions. Okay, first we're going to find the region of R. We know that R is going to be bounded by the x-axis. It's a square root of x, and the line of x equals 4. So I'm just going to draw it up here. We have our nice little plot. We're going to have a function that looks sort of like that. And we're going to have a cutoff at x equals 4 here. So we're finding this region here. To do that, we're going to be doing integration. Everyone loves integration. So we take the integral of 0 to 4 of the function square root of x dx. And that's literally what this area is going to be equal to, equals a. So now, basically, I think it's easiest to just change the square root into x to the power of 1/2. It just makes it cleaner and more intuitive to me when I'm doing integration. So I change it there, and then you're doing the adding, and then you divide by it. So this is going to become x to the 3/2, and then this 2/3. But of course we still need to evaluate it. So we evaluate it from 0 to 4, and that's going to be equal to a. So now we know fundamental theorem of calculus. We're going to take this 4 in, and then we see, oh, 0 is going to be nothing, so we don't need to worry about that. So we take the 4, we have the square root, which becomes 2 to the power of 3 times 2. That's going to give us 16/3, and then again minus 0 because it's x to the power of 3/2, and that's going to be 0. So our area will be 16/3. Okay, part B. Find the value h such that the vertical line x equals h divides the region R into two regions of equal area. So you can do this two different ways. You can do it such that 0 to h is going to, that's a very bad h, of the integral, I'm just going to do ... is equal to an integral h to 4, but I think this is more work. So we have the answer for the last one, which is just 16/3, and it's a lot easier in my opinion if I just take it and I'm going to make that into 8/3, and that's what the first one's going to be equal to, and it's going to be a lot easier to evaluate because there's a 0 in it inside of it, and then we don't have to evaluate 4. So we're going to have the integral of 0 to h of the square root of x is dx is equal to 8/3. Again, we already have this integral. We've done this in the last part, so we have 3/2 and 2/3 here. Again, we're evaluating 0 to h, and look, 0 does nothing, so h comes in. So we have h to the power of 3/2 times 2/3, and now it's going to be equal to 8/3. So we multiply 3 over, it's going to end up actually canceling out, and then we're going to divide, that becomes 4. So we have 4 is equal to h to the power of 3/2, and what we can do from there is you're going to square it to get rid of the 1/2. So then that's 16. And then you're going to take the cubic root, because we want to get rid of that to the power of 3, is equal to h. Part C, find the volume of the solid generated when R is revolved around the x-axis, or about the x-axis. So again, we're just going to have the same shape here, the same bound, and it's going to be revolved around this axis here. So again, not too bad, as long as you can remember that v is equal to pi r squared for when you're revolving something about an axis. And again, it's the x-axis. We have y in terms of x, so we're set. Okay, so we say v is equal to pi r squared. R is going to be equal to the integral of from 0 to 4 of square root of x dx. So we're going to have v equals pi, or the function r is in there, so of 0 to 4 square root of x is squared here dx, and basically we just evaluate now. So again, the square is going to cancel the square root here, so get rid of both of those really nicely, and we're left with a function of the integral of x, which is pretty easy to find. We have x squared 1 times 1/2, and we evaluate that there from 0 to 4. And of course it's times pi. Again, 0, really easy to find. We have 4 squared 16 divided by 2, 8. So we have 8 pi is equal to v. Okay, part D asks us, the vertical line of x equals k divides the region into R into 2 regions such that when these 2 regions are revolved about the x-axis, they generate solids with equal volumes. Find the value of k. This is another one where you can have this integral, this nasty integral, where you have a 0 to k is equal to this other integral that's k to 4. But it's a lot simpler if we just remember the last answer, which is 8 pi. And if you divide that by 2 and you have 4 pi, then you can just set the first one, which will evaluate so much nicer. And I think that's what you should do. So I'm going to set the integral from 0 to k. That's it. Sorry for this bad handwriting. We're revolving it, so remember again, it's the v equals pi times r squared, and we have this x in here. Dx is going to be equal to 4 pi because it's half. The 2 volumes must equal each other. First thing I'm going to do, get rid of this guy, and then I'm going to evaluate this integral. Again, the square and the square root cancel each other really nicely. So when we evaluate that integral, we're left with 1/2 times x squared, evaluated from 0 to k, is equal to 4. From there, what we're going to do is we can pretty simply evaluate k in here. Again, 0 squared is 0, and then 0 times 1/2 is 0, so 0 gets rid of itself really nicely here. So we have k squared 1/2. I'm just going to multiply that over, and we have 8. And now from here, we take the square root. We have k is equal to the square root of 8, And again, since it's a volume, you can't really have negative volume. So that's an answer to part D. Thank you for watching. I hope you guys enjoyed. Make sure to, I don't know, follow, like, subscribe, whatever those things I'm supposed to say. Enjoy the Minecraft parkour as well.